Hello everyone, in this video I want to show you guys this little project I made. It's basically it looks weird, but it's a projectile launcher. Let's say it's something like that. Basically, what this does is you can throw a projectile, let's say this, at a certain distance that you are going to measure using this ultrasonic sensor here. So we have three main components here, which is a servo motor, the ultrasonic sensor, and a Raspberry Pi. What it does is the ultrasonic sensor is going to measure the distance between here and another point, let's say here. And then after measuring this distance, it's going to use an equation to work out the angle, the necessary angle for this ramp to be set at, so that once I launch the projectile, which is this, it'll reach that exact distance the ultrasonic sensor calculated. So the Raspberry Pi is using an equation that depends on the gravity acceleration, the speed, the initial speed the projectile is thrown at, and also the angle. What I'm doing here is trying to make sure that the speed, the initial speed of the projectile will be constant all the time. That's why I have this mark right here. I'm always launching it, like stretching it all the way to this point and never going beyond that, so that I try to make the speed constant. I'm always using the same rubber band, the same conditions, so that I make sure the speed is almost constant. Of course, it's not going to be exactly constant, but so well, we all know how the trajectory of a projectile goes. It's something like, let's say you're throwing this projectile at this angle and at a certain speed under some gravity acceleration, let's say the gravity acceleration on Earth, and then you're releasing it, it's gonna go hit another spot like this at a certain distance from the launch point. And well, this distance is gonna change depending on the angle and also the speed. Since I'm making the speed constant, the only thing that's gonna change the maximum range I can reach is the angle. So let's say I change the angle to something like this, then once I throw the projectile, it's gonna reach another point. If I just set it at 45 degrees, which is gonna give me the maximum range I can get, it'll reach a much longer range. So basically this is the idea. Now I'm gonna show you the mathematical part for this. Of course we're using math, and let's see it. Alright, so these are there are three main equations I used for this. This is the first one. This equation is for the distance. So what I did here was to try and calculate the speed, because of course I had no other way to find it, so I just had to make this angle constant and also measure the speed, like literally do some practical testing and go there and measure not the speed, I'm sorry, the distance. So I would just throw this projectile at 45 degrees and then would go there and measure the distance it reached. Of course, I was given the same conditions all the time for the projectile to be launched, always using 45 degrees and stretching the rubber band the same way all the time, given the same conditions, so that I could get always the same distance, which would make the speed constant. And after getting the distance, I could just easily solve this for the speed. And then I found that the speed was 5.24 meters per second. And well, after using that out, I just plugged this speed into this another equation here. This equation gives me the angle. So basically the only variable here is going to be the distance. So the ultrasonic sensor is going to measure this distance right here, and I'm going to plug it into this formula. The gravity acceleration is going to be the gravity acceleration on Earth. The speed is going to be this speed I got from the previous equation. So both of these quantities are of these variables are going to be constant. The only thing that's going to change is the distance. And by changing the distance here, I'm going to change the angle. And after getting the angle, what it does is it's going to set the servo motor at this angle. And then after that, I'm finally able to launch the projectile, and it'll reach this distance. This is the other formula I used. This one is just to set the servo motor at the angle that we got from this equation. This is basically a step in the servo motor. So basically this is like 7. I figured that it will be 0 degrees, and then I add that to the angle I got from here. And let's say for example I got 45 degrees. It's at 7 at the step 7, it's 0 degrees, and then it's gonna set the servo motor at 45 degrees, and now I'm able to launch the projectile. So basically this is how it goes. I programmed everything, all of these in Python, and now I'm gonna show you guys the programming part and everything I needed for that, and show you some practical testing of the project working. Alright, so here's the code. I'm gonna leave it in the description so you guys can see it. I'm gonna leave a link on it, and then you guys can go see the code and download it. Basically what it does is it's gonna ask you to measure the distance, and if you say yes, then it's gonna call the ultrasonic sensor and measure the distance. After measuring the distance, it's gonna show you that distance in meters, and then it'll ask you to proceed. Just say yes, then it's gonna calculate the angle. Here's the equation for the angle. It's gonna calculate the angle that's necessary for that distance to be reached, and then after doing that, it'll set the servo motor at that angle. And once it sets the servo motor at that angle, you're now good to go. So you can just launch your projectile now. And that's basically what it does. Then it's gonna come back. It's a loop. It's gonna come back to this first question and ask you again, hey, do you want to measure the distance again? And then it'll give you the option to measure the distance. If you say no, then it's not gonna do anything actually. It's gonna ask you again if you want to measure the distance. But this is basically how it works. If you say no here, then it'll just come back here, just in case. Let's see, you see that the distance measured is kind of weird, and it's not exactly what you wanted. Then you can say no, and it'll come back, and it'll be available for you to measure the distance once again.